Okay, so this quadratic functions, first we have to know that quadratic function, it looks like this, as you can see here, this one, fx equal to ax squared plus bx plus c. So this is called quadratic function. So the coefficients of x squared, which is a, so if a is greater than 0 and the value of a increase, okay, so that means you should expect the shape of the graph to be a smiling face graph and becomes narrow and steeper. So if a increase, the graph is getting more and more steeper. Okay? If a increase, so for example, let's say I put y equal to x squared. So the graph supposed to be like this. Okay, so for this case, a is equal to 1. Now I put, let's say in blue color, y equal to 2x squared. So you should expect the graph to be steeper and narrow. So for this case, a is equal to 2. So that is what they're trying to say. When a is greater than 0 and the values of a increase, so the effect is from the red graph to the blue graph. Now the next one, when a is greater than 0 and the value of a decrease, so you should expect the other way around, from the blue graph to the red graph. The shape of the graph is still happy face and becomes wider and less steeper. So from the blue to the red, you will see it is getting wider and less steep. Now the next one, a is less than 0 and the values of a increase. Okay, so put example here for the third case. Example, a is negative. Let's say a is negative. Okay, let's use blue color. Okay, so y equal to negative 2x squared, and then y equal to negative x squared. So now let's see the graph. Y equal to negative x squared, the graph is going to be like this. And then y equal to negative 2x squared, the graph is going to be like this. Okay, now let's understand the information here. They say the third row again. The shape of the graph is set face graph. So as you can see, set face because a is negative, and becomes wider and less steep. Wider and less steep. That means this is from the blue to the red. So negative 2 increase to negative 1. So negative 2 increase to negative 1. That means the graph from the blue graph to the red graph, you should see something like the graph from narrow and steep become wider and less steep. So that is what they're trying to say. Okay, so we look at the next one. The fourth one, a less than 0 and the value of a decrease. If the value of a decrease is from red to blue, then red to blue, from negative 1 decrease to negative 2. Okay, so the shape of the graph is still set face and becomes narrow and steeper. Okay, so from red to blue, you can see the graph become narrow and steeper. Now next one, a is greater than 0 and b is greater than 0, or a is less than 0 and b is less than 0. The vertex of the graph is at the left of the y-axis. Okay, so I put one example for this. I start with A more than 0 and B more than 0. Okay, so let's say, put an example here. Y equal to 2x squared plus 3x plus 1. Okay, so you can see A is 2, B is 3. Okay, so which fulfill the condition over there? A is greater than 0. Oh, okay, the arrow should not be this, should be this one. Should be this instead. Okay, so you can see this condition again. A is greater than 0, B is greater than 0. Greater than 0, greater than 0. Okay, then they said vertex of the graph is at the left of the y-axis. So you see how we find the vertex. To find the vertex, you factorize it first. 2x plus 1, x plus 1, and then you know 2x plus 1 equal to 0, x equal to negative 1 over 2, x plus 1 equal to 0, x equal to negative 1. We get the two x-intercepts. So now I draw out the graph. Negative half, negative 1. So the graph is going to be like this. Oops. Like this. Okay. So this is 1. This is the vertex. So this point is vertex. So the vertex is on the left hand side of the y-axis, which is true. Okay? This is the y-axis. It's on the left hand side of the y-axis. Okay? So that is what they're trying to say for the first case. Now for the second case, they say A is still the same row. They say A is less than 0 and B is also less than 0. So I give one example here. Okay, let's say y equal to negative x squared, negative 2x, and let's say negative 1. Okay, let me check the calculator. I'm trying to create an example that can factorize. So let me see whether I can factorize this or not. Okay, so it's negative 1, negative 2, negative 1. Negative. Okay, yes, can factorize. So I factorize this to negative okay, so let's say there are many ways to do the factorization. The first way is I take out the negative first, then it becomes x squared plus 2x plus 1. Then I factorize, it becomes x plus 1, x plus 1. So from here I know that x plus 1 equal to 0, x equal to negative 1. The second factors end up with x equal to negative 1 also. So for this case, you can see the x-intercept is negative 1. Negative 1. For this case, right, if the two roots are the same, then you should expect the graph to touch and go at this value. Touch and go. Compared to just now, right? If the graph have two different x values or two different x-intercept, the graph does not touch and go. The graph cross the x-axis and cross the x-axis and then go. Okay, so if you have the same x-intercept, that means the graph will touch and go. Touch at negative 1 and then go away. Never cross. Okay, so this is negative. Okay, set face graph. So touch and go also, but this way. Negative 1. Okay, so the graph is like that. And again, you can see the information just now. in the note that said this row again, a less than 0, b less than 0, which is true. A is -1, b is -2, both are less than 0, and the vertex of the graph is at the left of the y-axis. Yeah, so this is the vertex. So the vertex is at the left of the y-axis. Now we see the other one, a greater than 0, b less than 0. Okay, so let's say this one, I put the example on this side. Okay, so I'm going to create an example where a is greater than 0. So let's say I create 2x squared. B is less than 0, let's say minus 3x. Okay, and let's say C is, let me see first, I try with calculator to create the value that I can factorize, so that it is easier to explain everything. So let's say, okay, plus 1. So you can see A is greater than 0, B is less than 0. Okay, so for this case, the information given there, see it again. The vertex of the graph is at the right of the y-axis, at the right. So let's see how true is this. Okay, so we factorize it. 2x x minus 1 minus 1. Okay, so we factorize it already. And then 2x minus 1 equal to 0, x equal to 1 over 2, x minus 1 equal to 0, x equal to 1. So from here we get the 2 x-intercept. Now I sketch the graph. So the graph is going to be like this, where here is half, here is 1. Okay, so then it fulfills the information here. The vertex is at the right. So this is the vertex. It's at the right hand side of the y-axis. Now a less than 0, b more than 0. This is another case. Okay, so let's create another example. Negative, positive, and let's say this is negative. Okay, so you can see a is less than 0, b is more than 0, and now we factorize it. Okay, factorize it. So negative 2x x plus 1 negative 1. Okay, yes. Now negative 2x plus 1 equal to 0. Then x equal to 1 over 2. X minus 1 equal to 0. X equal to 1. Okay, so again, the graph is kind of similar. Half and something like this. Here half, here 1, here negative 1. So y, x. Okay. So it fulfills the information here again. You can see the vertex of the graph is at the right of the y-axis. So the vertex is here, which is true, is at the right of the y-axis. Okay, now next one. The value of c increase. This one, the value of c increase. The graph is moved upward vertically. Okay, so let's see. Example. Y equal to x squared plus 1 to y equal to x squared plus 2. Okay, I create one simple example. So x squared plus 1 is like this. Cross at 1. Now x squared plus 2 is this one. Cross the y-axis at 2. So this is y equal to x squared plus 1. This is y equal to x squared plus 2. So what happened is the graph moved up vertically by 1 unit, from 1 to 2, So now next one. The value of c decrease. So you have to look at it in the opposite way. From x squared plus 2 to x squared plus 1, the graph will go down. So that is where the c decrease. The graph is moved downward vertically. So we finished all the information in the table. Okay, now let's see the question here. Based on the changing values of a, b, or c stated, sketch the graph of quadratic function on the given axis and state its effect. Okay, so part A, we have fx equal to 2x squared minus 5. Okay, 2x squared minus 5, that gives us a graph. Okay. Okay, so let's say to answer this question, we supposed to have two quadratic functions so that the changes can be seen. Okay, now let's say I have fx equal to 2x squared minus 5. Then after that I have let's say I have gx. Okay, I create a quadratic function here. Gx equal to, okay, let me see first. Let's say I change it to 3x squared minus 5. So if they give two quadratic functions, this question makes sense. Okay, so let's say they sketch this as fx. Okay, now when they give gx equal to 3x squared minus 5, okay, let's say okay, what happened is it belongs to the first scenario. A is more than 0. A is 2, and now the a increased to 3. A increased to 3. The shape of the graph is happy face and becomes narrow and steeper. So when you change the a only, the graph become, when you increase the value of a, which is positive, so the graph become narrow and steeper. Okay, now we can sketch the graph. The y-intercept still the same, but now because of 3x squared, right, the graph becomes steeper. So this red graph is gx. Okay, so supposed to give two functions, then the question makes sense. Okay, then what we can say here to state the effect, so we can say something like this. Just copy the first row. The shape of the graph is happy face and become narrow and steeper. Become narrow and steeper. So something like this. They're supposed to give two functions. We see the changes, then we can sketch the graph based on the changes. Okay, now, let's say question 1. Okay, question 1, let's say they give something like this. This is fx. Now they give gx to be 3x squared plus 2. 3x squared plus 2. Okay, so what happened is we have to look at this. The value of c increased from -5 to +2. The graph is moved upward vertically from -2 to -5. That means you should expect the y-intercept to be -5, and now it becomes +2. +2. So we draw the same graph again. Gx. Then the question makes sense. Okay, now we write the effect here. Just copy the second last row. the graph move upward vertically by 7 units. You know, -5 to 2 is 7 units. Okay, so something like this. Okay, so let's move on. This one's settled already. Okay, so we look at the next page. On this page, we are going to learn about discriminant. Okay, so discriminant is b squared minus 4ac. So if b squared minus 4ac is greater than 0, that means there are two real and different roots. Okay, so you should expect the graph intersect the x-axis at two different points that represent two different roots. And we have two kind of graph. If the coefficients of x squared, which is a, is greater than 0, then the graph is a smiling face graph, or else it is a sad face graph. So the graph of fx intersect the x-axis at two different points. Okay, so one quick example. You know, just now when I create example, right, one of my example is y equal to 2x squared plus 3x plus 1. This is one of my example. Okay, then I factorize it also. I factorize it to 2x plus 1, x plus 1. Then I also sketch the graph. So let's say I just repeat the thing quickly here. So I have -1/2 and -1. So this is the case where the graph intersect x-axis at 2 points. So if I go and count the discriminant, right? So, you know, a is 2, b is 3, c is 1. So if I do b squared minus 4ac, right? So I will get 3 squared minus 4, 2, 1. Then I count it, 9 minus 8, 1. So this is greater than 0. So you can see something that fulfill the information here. Your b squared minus 4ac is greater than 0. And your graph, you intersect the x-axis at two different points. So this is the example. B squared minus 4ac equal to 0. The two real and equal roots. So we have two real and equal roots. So something like this. We call this touch and go. Just now this one, I call it the graph crosses the x-axis. And now the graph touch and go. Okay, so likewise, yeah. This is a less than 0. So the graph is a set face graph and it touch the x-axis and go. Okay, so a quick example. Let's say I have y equal to x squared plus 2x plus 1. If I go and factorize it, I know that I have x plus 1, x plus 1. Okay, then I know that the graph is going to be here, -1. And then, you know, the roots are two same roots, then the graph had to be touch and go. So if I go and count the b squared minus 4ac, right? So you know, a is 1, b is 2, c is 1. So b squared minus 4ac is equal to 2 squared minus 4, 1, 1. 4 minus 4 equal to 0. So I will get b squared minus 4ac equal to 0, and that means one root or two real or an equal root. Okay, so you can call it one root. Sometimes you may see one root, sometimes you may see two real and equal roots, something like this. Okay, then the graph will just touch the x-axis at only one point. B squared minus 4ac less than 0, no real root. So no real root means you cannot factorize or you cannot find real numbers for your root. Okay, so your graph is above the x-axis or below the x-axis. Okay, so above or below. Never touch the x-axis. Okay, so let's say one example. If I have y equal to x squared plus 1. So the graph is going to be like this, where here is 1. Okay, so if I go and count b squared minus 4ac for this function, I will get, okay, you see for our case here, a is 1, b is 0, c is 1. Okay, so 0 squared minus 4, 1, 1 equal to negative 4, less than 0. So b squared minus 4ac less than 0, that is no real root. So you see, the graph never touch, never cross the x-axis. Okay, so now let's look at the example. Okay, so they give us this graph. Discriminant is b squared minus 4ac equal to 0 because they touch at one point. So that means 2 real and equal roots. Okay, one more example. If we have a graph like this, never cross the x-axis, so you should expect b squared minus 4ac less than 0. And then we should expect no real roots to be here. Okay, so you can easily look at the table on top and answer this. Okay, now let's move on. Part C. Determine the position of each of the following graph of quadratic functions. Position, we want the position. Hence sketch the graph. So example, fx equal to x squared minus 2x plus 6. You go and count the b squared minus 4ac, right? So you will get negative 20. So you should expect no real root, and you should expect the graph is smiling face because a is more than 0. So a smiling face graph which is above the x-axis never cross the x-axis because no real root. So the graph will be like this. Okay, so they ask you to determine the position, right? So you just say like this: graph of fx does not intersect the x-axis. Okay, so let's move on. Okay, now over here we have 3 questions. So for these 3 questions, I just leave it to you. Let's move on to the notes. When a quadratic function is expressed in the vertex form of quadratic function fx equal to a x minus h squared plus k, you want to get this form, you have to do completing the square. Okay, so I have to do completing the square. So once you do that, then you get this, and then you can find out the vertex easily. You see the vertex is this point. The coordinate is hk, which is from here, no? From the bracket and from the back. So the h is from here and then the k is from there. So that is the coordinates of the vertex. So how to get this form? Okay, let's see one quick example. How we get that form? Okay, if I have fx equal to 2x squared plus 3x plus 1. So I want to get the vertex form. I need to do completing the square. So first I have to factorize 2. Factorize 2. So then everything at the back divide by 2. Become 3 over 2x. For the last term 1, you can leave it outside. No need to do it. Okay, so leave it outside. Of course, if you want to factorize 2 from the back for the last term also, it is okay. So let's say example, I will do both. I know that different teacher teach different way, so end up with sometimes when the method are different, then students are confused. So I do both methods. So something like this. Yeah. Factorize 2 from all the terms, and this one factorize 2 from the first and second term only. So you can decide later which way you want to take. Okay, now I just continue first. I continue with this. So after you factorize 2, now you look at the b. This is the b. I call this b. Include the sign in front. So b is 3 over 2. Now you need to do b over 2 square. You have to add b over 2 square minus b over 2 square in b at the back of the first two terms, something like this. So you put 2, you write back the first term, the second term, and then you add b over 2. So I know 3 over 2 divided by 2 is 3 over 4. So this one I know already. So I just write straight away 3 over 4 square minus 3 over 4 square. That is my b over 2 square minus b over 2 square. I put at the back, and then plus 1. Okay, so then I can factorize these three terms. Factorize this. The shortcut is take this without the square, take this without the square. This is a shortcut to factorize. So you just take x plus 3 over 4 and then put them in square. That is the fastest way to factorize. And then minus with, okay, for this term, the fourth term, so you just expand it, 9 over 16. Okay, 9 over 16, close bracket, plus 1. Yes. Then now the 2 you multiply with both. 2 times this. We can't really times inside the bracket because of the power 2. So we just leave it like this only. But 2 multiplied with this is okay. 9 over 8 plus 1. 2 x plus 3 over 4 square minus 1 over 8. Minus 9 plus 8. Yeah, correct. Minus 1 over 8. So that is how we change it to vertex form. By doing... Yeah. Sorry?
Why need to multiply?
We need to multiply so that these two numbers can combine. Can combine and become a number so that it is of this form at the end. This form, where you can see the k, the plus k there. This is the k. If you don't multiply, right? If you don't multiply with 2, right? So this square bracket is always there. This square bracket is there, and then this number and this number you cannot count it, So you multiply this, and then these two numbers you can count and become a number that represent k. So vertex form. Okay. Now let's see this method. I don't know which method you are using, so I just show both. Kind of similar one. Okay, so let's see. Again, our b is 3 over 2. So you have to add b over 2 square minus b over 2 square after the first two terms. So you have to put something like this. Okay, I need more space right here. 2 x squared plus 3 over 2 x plus, okay, I know b over 2 means 3 over 2 divided by 2, so that is going to be 3 over 4. 3 over 4 plus half. Okay, so something like that. And you see, compare with just now. This is half. This one is outside, is 1. So at the end will be the same one. In between it look a little bit difference. Okay, at the end you will see it to be the same. Okay, so again we factorize the first three terms, and again the shortcut is take this without square and take this without square, which means take x plus 3 over 4. Okay, then for the fourth term, expand it, minus 9 over 16, minus 9 over 16 plus 1 over 2. So I just use calculator. Minus 9 over 16 plus 1 over 2 become minus 1 over 16, and we multiply 2 at the end. Multiply 2 with the first bracket, end up with something similar, but multiply 2 with negative 1 over 16 will end up with minus 1 over 8. Okay, so you will realize the two methods end up with the same answer. Okay, so this is called completing the square. Completing the square, and at the end we get vertex form. Vertex form means it is very convenient to find the coordinate of vertex. How to find the coordinate of vertex? You just take this, let it equal to 0, and then you get the x, which is negative 3 over 4. Okay. At the back of the bracket you have negative 1 over 8. This will be the y. So the y is negative 1 over 8. So we get the x and the y. This is the coordinate of the vertex. Negative 3 over 4, negative 1 over 8. Something like this. Okay, so we get the vertex. Completing the square, then get the vertex. Okay, let's see more information. Okay, too many information sometimes. Okay, now let's see. The equation of the axis of symmetry is x equal to h. X equal to h. Okay, what is that? It is this vertical line. This vertical line is called axis of symmetry because this vertical line cut the graph into half where both sides are same. Okay, so asymmetry we call it. Both sides are symmetry. So this is another example. This vertical line is axis of symmetry. Okay, so it make the graph symmetry. Okay, let's say for my case here, if I have done completing the square and get this, now let's say I draw out the graph. Negative 3 over 4, negative 1 over 8. So my vertex is here. Okay, that's my vertex. This one, just now I already factorized. 2x plus 1, x plus 1, if you still remember. X equal to negative 1 over 2, x equal to negative 1. If you still remember the two x-intercept. So the graph is going to be like this. This is negative 1 over 2. This is negative 1. So our note just now mentioned about the axis of symmetry, which is this one. The equation of the axis of symmetry is x equal to h. So which line is axis of symmetry? Is actually this line. This line, it passes through the vertex, and it takes equation x equal to the x coordinate of the vertex, which is negative 3 over 4. So this line is axis of symmetry. Okay, then now let's see the next point. The minimum value or maximum value of fx is k. Is k. K means the y coordinates. So if it's this case, a greater than 0, so this k is known as minimum value. If for the second case, where a is less than 0, end up with the graph is a set face graph, then the k is a maximum value. For our case here, okay, so as you can see, the y is negative 1 over 8. Our graph is a happy face graph because a is greater than 0 basically. Our a is 2. Okay, so we have a minimum value. So the minimum value is the y coordinate, negative 1 over 8. Okay, so minimum value equal to -1/8. Okay, now let's see the next one. The next information, the third point. The minimum point or maximum point is hk. Okay, so it depends on a. So if a is greater than 0, so this is the minimum point. If a is less than 0, then this is the maximum point. Okay, so how to get h and k? Always remember, you see our example just now. To get h and k, let the bracket equal to 0, get the x. To get the y, just take everything at the back of the bracket with square. Just take everything at the back there, then that is the y. So this is the vertex, and this vertex is a minimum point. So we call this a minimum point. So the thing is, after having vertex form, you can get 3 information. The first one is the maximum point or the minimum point. The second one, axis of symmetry. The third one, minimum value or maximum value. So 3 information can be obtained from the vertex form. Okay, now part B, number 2. For fx equal to ax squared plus bx plus c, which is expressed in the vertex form. So you want to express it in vertex form, right? So you have to do completing the square. You can also memorize the formula. See? H equal to minus b over 2a. K equal to c minus b squared over 4a. You can memorize, then you can get the h and k straight away. So if you can memorize, then just go ahead. Let's see example. Okay. I use the same equation again. I know a is 2, b is 3, c is 1. I know the formula is h equal to b negative b over 2a. Negative b over 2a. I know k is c minus b squared over 4a. Okay, so this is where you memorize up the formula and you find the h and k straight away. So you want to find the h, right? The x coordinate of the vertex. Minus 3 over 2, 2. Minus 3 over 4. Which is very fast, So you see, minus 3 over 4. Same one. You want to find the k, right? You must get -1 over 8. So let's use this formula and see. K equal to 1 minus 3 square over 4, 2. K equal to 1 minus 9 over 8, which is -1 over 8. So we get the h and k, which is this one. Same value. And it's so fast, no need to do all this completing the square. So it's up to you, We have to be flexible after all. Okay, now let's see how they ask. Okay, you see part D. Based on the given quadratic function, complete the table below. So they give vertex form. Equation of the axis of symmetry, x equal to 4. From where we get 4? From the bracket. You let x minus 4 equal to 0. Imagine x minus 4 equal to 0, then you get x equal to 4. So you let everything in the bracket equal to 0, then you get 4. Okay. So that is axis of symmetry. The minimum value is 8. From where? From here. This is the y. Positive 8 is the y. So the y is the minimum value. Why we call this minimum value? Because a is greater than 0. The graph is a smiling face graph. So a is 6 for our case here. Then the minimum value is this one. The minimum point is the x, which is 4, and the y, which is 8, 4, 8. Okay, let's see one more example. Okay, let's say this one, number 5. Axis of symmetry, look at the bracket, x plus 10. Imagine x plus 10 equal to 0. So x equal to minus 10. Now for our case, a is negative 4. Negative 4 less than 0. We know the graph is going to be a set phase graph, so we should call this maximum value. Maximum value is equal to 27. It's everything at the back of the bracket. And then the maximum point is the x negative 10 and the y positive 27. Something like this. Okay, so we have done. Let's move on. Okay, so on this page, express each of the following in the intercept form. So fx equal to a x minus p x minus q. That means factorize it. Okay. Hence state the values of a, p, and q. Okay, let's say example. They are giving us the vertex form, but they want intercept form. Okay, so what we do is we expand it. X minus 1, x minus 1. And then you times x times x, x times minus 1 times x, minus 1 times minus 1. So you end up with x squared minus, straight away, minus 2x plus 1 minus 12. Okay, so then expand 3x squared minus 6x plus 3 minus 12, 3x squared minus 6x minus 9. Okay, so they want intercept form. Intercept form means you factorize it. I factorize 3 first. I know that all terms are divisible by 3. So I factorize. Then I factorize again. X minus 3, x plus 1. If you can factorize straight away, then you just do like me. If you can't factorize straight away, then you can do like this. X times x becomes x squared. Then you think of how to get negative 3. Negative 3 times 1, you will get negative 3. You cross multiply to double check whether this is correct or not. Minus x times minus 3, minus 3x. X times 1, you get x. Then you add up. Minus 3x plus x minus 2x. So it is correct if you can get the middle term. And then you take the first row. You take the first row to be the first factors, x minus 3. Then you take the second row, x plus 1, to be the second factor. So 2 factors. So once we get this, we get intercept form ready. Okay, then we just say that a is 3, p is 3, q is negative 1. Okay, so this is intercept form. The usage of intercept form is to find the x-intercept. Okay, is to find the x-intercept. Okay, now let's move on. This is part E. Okay, now we look at part F. Express each of the following quadratic function in the form of this. This is vertex form. Hence, find the minimum point or maximum point. This one we have gone through just now. I already explained to you how to do completing the square. First, factorize minus 3. What they do is they factorize minus 3 from the first and the second term only. The third term, they leave it there. So, you see, they factorize from here and here. So this one divided by minus 3, you get x squared. This one divided by minus 3, you get negative 4x. So after that, your b is negative 4. So you take b divided by 2, b over 2 minus b over 2 square. B over 2 square minus b over 2 square, put after the second terms. Then they factorize. You see they are using the shortcut also. They take this without power 2, take this without power 2. So this one, x, put here. Minus 4 over 2 is negative 2, they put here. Then they put bracket and square. And this one, expand it. Minus 2 power 2 is 4. Minus 4 at the end. So that's why you see minus 4. Now, what they do is, like what I explained just now, they multiply negative 3 with this, multiply negative 3 with this. So why you need to multiply? So that you can add up with the number at the back later. So minus 3 times minus 4 become positive 12, and then 12 plus 8 get 20. So we get this form. This is vertex form. So first you look at A. A is negative 3, less than 0. So you should expect the graph to be set phase graph. So set phase graph, there is a maximum point. So that's why maximum point you take from here and here. You let the bracket equal to 0. X minus 2 equal to 0. Then x equal to 2. This one is y. Y is 20. So like that. Okay, so this one I explained already. This is the second round. Okay, now let's see a little bit more. Determine the equation of the axis of symmetry and the minimum value or maximum value for each of the following. Okay, axis of symmetry is the h. H equal to minus b over 2a. Minimum maximum value is a is more than 0. Maximum value when a is less than 0. So to find the maximum minimum value, right? So the formula is the k. K equal to c minus b square over 4a. So they are using this. So you can see a, b, c can be found from here. Now they find the x, minus b over 2a. That means they are using this formula. Minus b is a over 2a, a is 2. Count and get negative 4. That's the axis of symmetry. Now you want to find minimum value. Why this is minimum value? Because a is greater than 0. A is 2, greater than 0. So minimum value. So to find minimum value, you use this formula, c minus b squared over 4a. So substitute, and then I get negative 15. So when you're doing this, you can avoid completing the square. Okay, so let's move on. Okay, so over here. Okay, so I think this one I leave it for next time, as there are too many information here. So I just leave it for next time. Okay, now it's your turn to practice.